Skill 39, Scatter plots and regression. Our goals today are going to be to write linear functions of a line of best fit and use that trend line to make predictions. A scatter plot is a collection of points on a coordinate plane, generally resulting in some sort of pattern. The trend line is a line that generalizes the pattern given in the scatter plot. It's not going to be exact, but it's going to be a rough estimate of a good estimate. Okay, now we're going to make a scatter plot of the data of the gallons that you put in your car versus the cost. So we're going to call the cost Y and the gallons X. It doesn't really matter. You could do it the other way as long as it's consistent and you label it. But cost, we're going to put going up. And then gallons, we're going to put going across on the bottom. Make sure we label it. And then we just graph our points. So when we're graphing our points, we're going to go over on the X and then up on the Y. So 2.5 up to 10, which would be like right here. 2.8 up to 11, which would be like right here. 2.3 up to 9, so like there. 2.6 up to 10, so that's kind of next to that other point that we already put there. 3.3 up to 13, so that would be like right there. I mean, these don't have to be exact, it just has to be kind of in the right area. Then 1.3 up to 5. And then we have 2.2 going up to 8. And 1.1 going up to 4. So then that would be our scatter plot. We have labels on it, and we have our axis labeled, and then we have just points for all of the data points in our table. One thing we want to note is there are different types of relationships in scatter plots. These types of relationships we call correlation, and the correlation is either going to be kind of generally it's going up, generally it's going down, or there's like nothing in common with anything. So this first graph, we can kind of see how the points kind of start down low, but then as they progress, as the X gets bigger, the line kind of goes up. So I would say at this point, this one right here looks like it is positive correlation. This means that the slope of the line is positive. That's what the idea of positive correlation means. Okay, so if I look at the next one, it kind of starts up high and then it goes kind of down as it continues on. So this would be a line that goes down, so that is negative. So for this one, since it goes down, we would call that negative correlation. In these cases, the M would be a negative number because it is going down. All right, and then this third example here, it kind of is just all over the place. The points are just kind of random. There's no rhyme or reason to where they are. So in these instances, we would say there appears to be no correlation. Okay, so you can either have positive, negative, or none. And if it is no correlation, then we pretty much can't do anything with it. There's no relationship between the two variables, so there's really nothing we can say about it. When writing the equation of a trend line, we have 3 steps that we gotta do. The first step is we have to pick some points. And we're going to strategically pick these points so that they kind of cut the graph in half. Okay, so we're going to pick these points so they split the graph. Once we pick the 2 points, then we're going to find the slope between the points. Okay, as a reminder, the slope formula is m equals y1 minus y2 over x1 minus x2. We've been doing that for a long time now, so that is the slope formula we'd use. And then we're going to find the equation of the line by doing point slope form. Put the slope and a point, one of the 2 points, in point slope form, which is y minus y1 equals mx minus x1. So you're literally going to put the m in that you already found, that same m, and then pick one of the 2 points that you had already picked and put it in, and then simplify it down and put it into y equals mx plus b format, and then that would be the equation of your trend line. All right, so let's do an example of that. So the first thing we're going to do is pick 2 points that kind of seem to cut the data. Now, these might not be the same for everybody, but as I'm looking at this, I'm seeing this point right here that looks like it's 10, 0. And this point right here, which looks like it's 0 and then up to like 80. Those 2 points look like if I draw a line between them, there's some points above, there's some points below, but it's a pretty nice graph. So I picked 2 points. So my 2 points that I picked are 10, 0 and 0, 80. Once you pick your 2 points, then we're going to find the slope. So m equals y1 minus y2 over x1 minus x2 slope. So put my points in. 0 minus 80 over 10 minus 0. So that would give me negative 80 over 10, which is going to be a negative 8. So m is negative 8. All right, once you have your m, then we use our point slope form, y minus y1 equals mx minus x1. And put in my points and my slope. So I pick one of the points. It does not matter which one. If I pick the first point, y minus 0 equals my m, which is a negative 8, x minus my x1, which was 10. And then I solve that. So I'm going to distribute in, and when I say solve, I mean solve for y, put into slope-intercept form. So I'm going to distribute that, and I have y minus 0 equals negative 8x plus 80. I mean, then technically I would add that 0 over, but it's just 0, so it doesn't even need to be there. And my final answer is y equals negative 8x plus 80. And that is a general estimate for this information. So that wraps up your notes on scatter plots. You should be able to now work through the assignment and be prepared for a quiz.